We are in chapter 12.1 with arithmetic series and sequences. Here is a real life example. Ophelia Gonzalez sells houses in a new development. She makes a commission of $37.50 on the sale of her first house, and then to encourage aggressive selling, Ms. Gonzalez's employer promises a $500 increase in commissions for each additional house sold. Thus, on the sale of her next house, she will earn $42.50 commission. How many houses will she have to sell in order to make $65,000 in a year? A sequence is a function whose domain is a set of the natural numbers, so the counting numbers. The terms of the sequence are the range elements of the function. The difference between successive terms of the arithmetic sequence is a constant called the common difference and is denoted by a d. An arithmetic series is the indicated sum, so what you do is take all the terms of the sequence and add them together, and you have what's called a series. Then find the next four terms in the arithmetic sequence, -7, -5, -3. What you have to do first is find the common difference. So the difference from here to here is 2. The difference from here to here is 2. So we're just going to add 2 here. So the next term is going to be -3 plus 2, which is -1, plus 2 is 1, plus 2 is 3. So those, and we need 4, so plus 2 is 5. So the next four terms are -1, 1, 3, and 5. Now let's find the 38th term. Well, the way that you do that is you have a formula. The of the n, so a sub n is equal to the first term plus n minus 1 times d. Well, if we're looking for the 38th term, the 38th term is equal to the first term, which is our -7, plus 38 minus 1. I got to shut him up here. 38 minus 1 times our common difference of 2. So our 38th term is equal to -7 plus 37 times 2, 74, which is 67. See that? Write an arithmetic sequence that has 3 arithmetic means between 3.2 and 4.4. So what an arithmetic mean is I've got 3 terms in between those, 1, 2, 3, and then 4.4. So what I need to do, I've got this a sub n is equal to a sub 1 plus n minus 1 times d. I've got everything except for the d, see? So my last term is equal to my first term plus I've got 1, 2, 3, 4, 5 minus 1 times d, and I'll just find what my d is. Subtract 3.2. 1.2 is equal to 4d, and divide by 4. So d is equal to 0.3. Now I'll just add 0.3 onto 3.2, and I'll get 3.5. Add 0.3 and I get 3.8. Add 0.3 and I get 4.1. And those are the 3 arithmetic means in between 3.2 and 4.4. Now we're on to series. So find the sum of the first 50 terms in the series 11 plus 14 yada yada plus 158. The equation for a sum is S sub n is equal to n over 2 times the first term plus the last term. So if we're looking for 50 terms, we have the sum of the first 50 terms is equal to 50 over 2 times the first term plus the last term. And that gives us 4,225, because you add those first and then multiply it by 25. Now we can solve Ophelia's problem. She has her S sub n is equal to 65,000. So she wants all of these things added up to be 65,000. Her first house is 3,750, and the common difference is 500, right? So our S sub n is equal to n over 2 times a sub 1 plus a sub n. We have to find our a sub n. See, we're looking for how many houses she'd have to sell to make 65,000. So we have 65,000 is equal to n over 2 times the first house. And now we have to find the last house. Well, the last house is a sub n is equal to the first house, 3,750, plus n minus 1 times your common difference of 500. So that is 3,750 plus 500n minus 500. So we got 3,750 minus 500 is 3,250 plus 500n. We take that and plug it in there. $65,000 is n over 2 times 3,750 plus 3,250 plus 500n. Multiply both sides by 2 to get rid of that 2. 130,000 is equal to 3,750n plus 3,250n plus 500n squared. Set this equal to 0 and plug it into your quadratic formula, and you get n equals some negative number, which you don't get to use, and then 10.78 or something. So she has to sell about 11 houses in order to make her 65,000. But ladies and gentlemen, that's what you go through to find that, which is pretty arithmetic, algebraic, pretty easy. The end.